All right, let's jump right in. You hear about AI agents all the time, right? And the big assumption is that they're all powered by these massive, super genius AI brands. But what if that's not just overkill? What if it's the completely wrong way to think about it? Well, some new research is flipping that entire idea on its head.
First, let's just get a sense of the scale here. $200 billion. That's the projected value of the AI agent market by 2034. We're talking about a technology that's expected to be a gigantic pillar of the entire economy. It's huge.
And this is the bet being placed on the current way of doing things. $57 billion, just in 2024 alone, invested in the cloud infrastructure that powers these big agents. That's a massive capital gamble, and it's all based on one idea, that bigger is always better.
But that really is the multi-billion-dollar question, isn't it? A pretty provocative new paper from researchers at NVIDIA is challenging this whole paradigm. They're basically suggesting that the industry might be building these massive gas-guzzling engines when a smaller, finely tuned electric motor would do the job way better.
And they do not mince words. This one sentence just cuts right to the heart of it all. They're arguing that for most of the stuff we actually use AI agents for, these giant models are, just the wrong tool for the job.
So let's meet our two main players in this debate. On one side, you've got the large language models, the LLMs. These are the generalist giants we all know and hear about, like GPT-4. They're designed to do a little bit of everything pretty well. But on the other side, you have the small language models, or SLMs. Think of them as the specialized experts built to do one thing perfectly. And often, they can do it right on your own device.
Okay, so what is an SLM really? Let's forget all the abstract stuff about parameter counts. The paper gives us this really simple, practical definition. It's an AI model that can fit on a device you already own, like your laptop or even your phone, and run fast enough to actually be useful. In other words, it's accessible AI.
The whole case for these SLMs really boils down to three big things. First, they're already powerful enough to get the job done. Second, they are way more economical. And third, they're more flexible, which just opens the door for way faster innovation for everybody. So let's break that down.
Now this really drives home that power argument. I mean, we are not talking about toys here. You have a 7 or 8 billion parameter model from Salesforce or DeepSeek getting performance that's on par with the absolute titans, like GPT-4o and Claude 3.5, for specific jobs like tool calling. They are seriously punching above their weight class.
And now for the money part, the economics. The difference is just staggering. The cost to run a single query, what we call inference, on a small model can be anywhere from 10 to 30 times cheaper than on a large one. We're talking about a massive drop in energy use, in latency, and, of course, in pure financial cost.
And then there's this, which is huge, the speed of development. Let's say you need to teach an AI a new trick or fix some weird behavior. With a small model, you can fine-tune it and have it ready to go in a matter of hours. With a giant LLM, you could be waiting weeks. That kind of agility is an absolute game changer for anyone trying to build and improve things quickly. I know what you're probably thinking, though. For years, we've all been told that in AI, size is everything. The famous scaling laws, they show that as models get bigger, they just get smarter. So, how can these smaller models possibly even compete?
Well, the paper tackles this exact question head-on. The common belief is that these scaling laws are absolute. But here's the rebuttal, and it's so important. Those laws assume you're using the same blueprint, the same architecture. SLMs are often built differently, more efficiently. And even more critical, you can cheaply fine-tune an SLM to become a world-class expert on one specific task, letting it easily blow past a generalist LLM.
Which, of course, brings us to the next big question. If these little specialized experts are so good, so cheap, and so flexible, why is the world still dominated by the giants? Why isn't every AI agent out there already using them? So the paper points to three main hurdles. First, you've got those massive investments we saw earlier. That creates a ton of inertia. Second, we're often testing SLMs on the wrong things. It's like giving a calculus exam to an award-winning poet. And finally, they just don't get the same media hype. But here's the thing. Notice that none of these are fundamental technical flaws. They're just practical hurdles we can overcome.
And the researchers don't just point out the problem and walk away. They actually offer a solution. They lay out this really clear 6-step process for businesses to basically create their own little teams of specialized experts.
It's a blueprint. It takes you from logging your current agent data all the way to fine-tuning and constantly improving smaller, more efficient models for each and every job. And hey, this isn't just a theory. The paper actually looks at case studies of popular open-source agents. For an agent called Cradle, they estimate that 70% of its calls to a big model could be replaced by a small one. For MetaGPT, that number is 60%. The potential for savings and efficiency is just enormous, and it's there for the taking, like right now.
So the author's conclusion is really a direct call to action. They argue that when you have the potential to make AI more efficient, more accessible, and more sustainable, exploring this shift away from giant models isn't just a good idea, it's basically a responsibility for the entire industry.
So it all leaves us with this one final thought. Are we building towards a future that's dominated by just a few centralized, superintelligent AI brands? Or is the real future a decentralized, dynamic, and efficient swarm of countless specialized experts, each one perfectly suited for its task? This paper makes a really compelling case that the swarm is coming.